Hey everybody, we're going to get to some real quick trig examples. Okay, if you have done transformations in other parts of graphing and whatever, this should be a little bit of review, but I'll try and attach that to what we know beforehand. Okay, back to the story here. Okay, y equals x. Guess what our graph looks like? Nice and easy. Okay, y, that's really y equals 1x. Where 1, 1. Okay, let's say I had y equals 2x. Well, you know, that looks like a slope of 2 now, okay? Simple as that, okay? So just maneuvering things, plus 1, there you go, moved it up 1, okay? Easy, easy, easy refresher, okay? There's nothing really different to that when we enter trig. It's just that we're using things that look a little foreign, scary. Don't be scared of this, just let's hit it dead on. Okay, sine function. As we've seen before with how to graph a sine function, we have a typical, we have a range of 1 to negative 1, so positive 1 to negative 1, and our sine function basically goes like this, okay? And it ends at 2 pi. Okay, that's basically after we have a unit circle and we've gone around the entire thing. Okay, that's our 2 pi radians to go around the circle once, and this is the resulting. If you analyze all the ratios of the p, you go all the way around through here, like all the p's that you get, you'll get a nice, beautiful curve that looks just like this, except better looking. Okay, so that's the simple y equals sine theta. Now, we'll look at a couple types of things here. This is 1 sine theta. Okay. There's two things we can do. We can change this number or change this number. That's not 10, that just says 1 theta. Okay? We can just change one of those numbers. Now, I just got to refresh myself for a second here. Right. If we had something that was 10 sine theta, just pretend that 1's not there right now. All I would be doing is changing the amplitude. So you need to realize this is like changing the amplitude. So instead of a nice, what I did is I shrunk the graph to make it fit. What you'd have is, instead of having a typical sine wave like this, you'd have a sine wave that looks like this. Okay, like instead of going to a height of 1, it's going to go to a height of 10. A height of negative 1 is going to a height of negative 10. Okay, so I just changed the scale to show the same thing. Now we're at a height of positive 10, height of negative 10. Okay, this didn't change. We still have one period, one cycle within our 2 pi. That's what that's all about. Okay, now suppose you had to look at this here. This is what we have. That's this. I'll just start another way. Y equals sine 1/2 theta. Okay. Now, instead of dealing with amplitude, we're dealing with cycles. Okay. I want you to think about it like this. What we're saying is that 1/2 of a cycle goes by over 2 pi. Okay? So nothing too tricky. Before it was one cycle, we could see one whole cycle went by at 2 pi. Well, surprise, 1/2 cycles go by at 2 pi. So guess what this the thing is going to look like? When we get to 2 pi here, it's not going to be a full cycle. Half a cycle is halfway point. Well, half a cycle then, if we only get a half cycle at the point 2 pi, well, that's what we're looking at. So we'll use our brains to implicitly figure out where this would finish. Well, this is halfway. The other half is going to look like this, sort of. And if that's halfway, then that means the full way is twice the halfway. 4 pi. So one cycle gets completed over 4 pi. That's how that fits into gear. Okay? So this little short video is dealing with amplitude and cycles. Quick little example of using both. I'm just making this up on the spot now because we know what we're doing here. Y equals 3 sine 1/3, no, we'll do it this way, 4 theta. Okay, what do we have? Well, this means that 4 cycles go by over the course of 2 pi radians. Oh, that's going to be tight. And this shows an amplitude of 3. Looking at it, minus 3 plus 3. That'll be the tops and bottoms of our graph. 2 pi is somewhere on here. Looks good to me. 4 cycles go by over through 2 pi. So that means we're going to have 4 complete cycles. This is our complete cycle. 4 of them. It would be smart to divide this properly into 4. So that'd be pi half, that'd be pi, that'd be 3 pi halves, 3 pi halves, and 2 pi. So what that is telling us, there's 4 cycles to the end of this thing, so I'll have one that looks like, oh man, 1 complete cycle there, another complete cycle there, another complete cycle there, and another complete cycle there. So our nice, beautiful, nice curvy sine curve has been compressed and stretched upwards. Okay? How many cycles over 2 pi? What the amps is, and that's how high and low you go. Give me a holler if you have any questions.